The Sun, Our Star by Megan Angeli. Today we're going to learn a little bit more about the sun. We're going to learn about what it's made out of, how big it is, what its layers look like, and also some cool solar activity on its surface that we don't get to see. So what is the sun? The sun is a massive star that provides heat and light for our solar system. The sun is essential for life on Earth. If we start at the smallest level with the plants, you think about how plants require sunlight for photosynthesis. If photosynthesis didn't happen, the plants wouldn't survive, therefore the animals wouldn't survive, and if humans didn't have plants or animals, we would also not survive. So you can see how sun is essential for life, even on the smallest level of plants, and also for heat and light for humans for survival. Also, we're going to learn about how massive the sun is. And the larger mass an object has, the greater gravitational force it is. Because the sun is so large, its gravity is actually going to keep all the planets in line in their orbits in our solar system. So how big is the sun? Let's imagine we take all of our planets in our solar system and combine them together. If we were to compare the sun is still 1,000 times larger than that mass. So that kind of just puts into perspective of how much mass the sun actually has. If we were to build a scale model of our solar system, we could represent the sun with a grapefruit. In comparison, the Earth would be about the size of a pinhead, rotating about 15 meters away. So what is the sun made up of? The sun is made up of burning, churning hot gas, mostly hydrogen and helium. And gas at this temperature is also known as plasma. The different properties plasma has, such as its temperature and density, create various layers within the sun's structure, and we're going to take a closer look at those now. Solar structure. Starting with the core, moving into the radiation zone and convection zone, those make up the interior of the sun. The sun's atmosphere is made of the photosphere, chromosphere, and corona. So we'll take a closer look at each of these layers, what their temperature is, and kind of what their function is within the sun. So we'll start with the core and make our way out. The core of the sun is the source of the sun's energy. This energy is created through the process called nuclear fusion. Nuclear fusion occurs when two atoms are moving so quickly that they collide and fuse together and release all that energy they had when they were moving. So specifically within the sun, it's usually two hydrogen atoms that collide to form helium. They fuse and release all that energy, and we receive it from the sun as heat and light. If we look at the temperature within the core, it's about 15 million Kelvin. In relation to the rest of the sun, this is the hottest spot, and we will see that as we move out. Going into the radiation zone, we're going to see that energy that was created by fusion traveling as photons. And photons are physical packets of energy. The temperature here cools down compared to the core to about 10 million Kelvin. Next, move up into the convection zone. And once we look at what convection is, you're going to understand why it's named this. Convection is a process in which warmer, less dense matter rises and cooler, more dense matter sinks. So if you think about your house in the winter when you have the heat on, when you go upstairs, it's going to be warmer than it is downstairs. And that's because the hot air rises in the house and the cool air sinks. So in the same manner, the plasma within the convection zone carries the energy up when it's warmer and less dense, and makes the energy sink when it's cooler and more dense. Again, this layer is cooler than the one before, so as we move from the core out of the interior, it's going to be about 5 million Kelvin in this layer. The first layer of the atmosphere is called the photosphere. The photosphere is the visible surface of the sun that we see in pictures. So when you think about a picture of the sun, we see a solid line, outlining the sun. The surface of the sun is actually turning and turning like a pot of boiling water. So if you think about when you go to make mac and cheese, you take your pot, you fill it with water, and you put it on the stove. We don't put those noodles in until that water is rapidly boiling. So if you can imagine those bubbles, churning and turning and causing all that movement, that's really what the sun is like on its surface. Also, this layer is the one with sunspots. And sunspots just appear in pictures when the sun's surface is interrupted by magnetic fields. We're going to take a closer look at those later on and what happens when magnetism affects the sun. But additionally, if you look at the temperature here, it's about 6,000 Kelvin. This is a big decrease compared to our interior. So again, as a recap with our temperature movement, when we start from the core and move out of the interior, the temperature is going to decrease. But when we move from the interior portion to the sun's atmosphere, the temperature is really going to decrease. So we are about 6,000 Kelvin in this layer. Next, we move up to the chromosphere. The chromosphere is the middle layer of the sun's atmosphere. Okay, so if we look at the temperature in the atmosphere, we're again going to increase as we move up and out. The chromosphere is important because this is a layer that radiates most of the sun's harmful ultraviolet waves. We've heard about ultraviolet waves probably as UV light. And we talk a lot about UV light when we talk about sunscreen and protecting our skin, and that's because UV light is dangerous to us and can cause us to form cancer. We are protected on Earth by our atmosphere because of our ozone layer. So when you hear people talk about global warming and the effects that it has on the depletion of our ozone layer, this is why it's important, is to protect us from these deadly UV rays that the sun emits. The final layer of the sun is the corona. This is the outermost layer, and it extends millions of kilometers above the sun's visible surface. It creates this large outer envelope of extremely high temperature but very low density gas. The temperature here dramatically increases to about 1 million Kelvin. So again, as we move out of the atmosphere, the temperature is going to increase. So now we'll take a look at some other solar activity that happens on the surface. The first of these is solar wind. The solar wind is a stream of charged particles that is constantly being emitted from the sun in all directions. So the wind is being represented by these orange arrows coming out from the sun. And if you look at our little blue comet, it's actually, the tail is not being caused by movement, it's caused by the solar particles flying by the comet and causing that color to be emitted. If you take a look at this picture below, you're going to see kind of an arch. This arch is called a solar prominence. This happens when the magnetic activity traps gas from the corona and the chromosphere and creates these giant loops of these gas just traveling in a loop. These can extend up to 100,000 kilometers above the surface, and they can stay that way for days or even weeks. Now, if we think about these magnetic lines that keep these loops in order, they eventually snap. When these lines do snap, they violently release the trapped contents and create something we call the solar flare. A solar flare is dangerous because it shoots deadly X-rays into interstellar space. Again, any of this information from our presentation today is available in our textbook, and any of the images you saw on the slides are available at these websites with further information.